How exactly do we power the cloud 24/7 without burning coal? It's a question that's literally defining the future of our entire digital world. You see, the cloud, it feels invisible, right? Kind of like this ethereal thing just hovering above us. But the reality is, it demands a massive, grinding physical infrastructure. We're talking millions of servers stacked in sprawling warehouses, massive cooling systems fighting off the insane heat from microprocessors, and thousands of miles of subterranean cables. And to keep all of that running without a single second of downtime, it requires an unbelievable amount of electricity. Well, in this explainer, we're diving into a profound shift in how we generate power. We're calling it the Geothermal Dawn. It's this relentless quest, led by Google and Fervo Energy, to secure constant, zero-emission electricity. We are talking about grounding the limitless expansion of our digital lives right into the ancient, unyielding heat of the Earth itself. Because here's the thing. Data centers are the engines of modern society, and man, they are hungry. Get this, they consume roughly 1% of the entire global electricity supply. Seriously, that is a staggering slice of the global energy pie going exclusively toward our search queries, our video streaming, financial transactions, and vast digital storage networks. And as our digital demands just continue to explode, mostly driven by the massive computational requirements of things like AI and machine learning, that hunger for power is only moving in one direction. It's accelerating. A typical modern data center, it can require as much power as a mid-sized city. So to fuel these massive hubs, tech giants can't just rely on traditional grids burning natural gas or coal anymore. They need a solution that isn't just clean, but relentless. Power that never falters, never drops, and never pollutes. Now you might be wondering, what about wind and solar? Well, here's the fundamental challenge with our current clean energy mix. Wind and solar are absolutely incredible resources, no doubt about it. They've completely revolutionized how we think about green energy, but they share a critical, unavoidable flaw. They're intermittent. The wind eventually stops blowing. The sun sets, or, thick storm clouds roll in. And when those elements fade, power generation simply drops off a cliff. But data centers? They never sleep. The internet doesn't just power down at midnight. Geothermal energy, however, provides a completely different dynamic. It offers a reliable, round-the-clock foundational power source. The Earth's internal heat does not care about the weather. It doesn't care what time of day it is. It's this steady, unyielding heartbeat that the grid desperately needs to stay green at all hours, basically acting as a permanent baseload to support the fluctuating nature of wind and solar. So how do we access this constant power anywhere we actually need it? Because traditional geothermal plants are geographically locked. You essentially have to get lucky and find a naturally occurring hot spring close to the surface, like they have in Iceland or parts of California. If the geology doesn't perfectly align, well, you're out of luck. But Google and Fervo Energy, they are engineering a massive paradigm shift using what are called Enhanced Geothermal Systems. They are literally creating artificial hot springs where absolutely none existed before. And the way they do it is brilliantly ironic. They are taking controversial drilling techniques straight from the oil and gas industry and deploying them to unlock completely clean, zero-emission energy. It's crazy, right? By marrying the aggressive extraction methods of the fossil fuel era with a desperate need for sustainable power, they are completely rewriting the rules of where and how geothermal energy can be harvested. Let's take a subterranean journey here because the massive industrial scale of the engineering happening right beneath our feet is just staggering. First, massive rigs drill 7,000 feet straight down. Think about that, 7,000 feet directly into solid, unforgiving rock. To put that into perspective, that's well over a mile deep, penetrating layers of the Earth's crust that have literally sat undisturbed for millions of years. Once the drill hits that incredible depth and hits intensely hot rock, the trajectory turns completely horizontal. Then, engineers deploy hydraulic fracturing, yes, fracking, to blast a highly engineered network of tiny fissures through the rock, connecting two parallel wells. They are taking the exact heavy industry tools used for decades to extract oil and natural gas and turning them into precision engines for zero-carbon power. It's an aggressive, calculated manipulation of the Earth's crust, forcing it to yield its deep thermal energy. Okay. So, with that underground network built, the actual power generation kicks off through a massive, closed heat exchange loop. Here's how it works. Cold water is continuously pumped down that first well under immense pressure. As it forces its way through those freshly fractured fissures in the superheated rock, it acts like a giant thermal sponge. The deep Earth is essentially acting as a limitless furnace, rapidly transferring its thermal energy right into the fluid. The superheated water is then forced back up the second well. By the time it breaches the surface, that water's at a blistering 375 degrees Fahrenheit, sometimes even hotter. That massive, continuous rush of thermal energy hits the surface plant, flashes into steam, and drives massive power-generating turbines with unyielding consistency. It's a relentless loop. We are literally turning ancient heat into modern electricity. But listen, this isn't just brute force industrial engineering. This is where heavy industry collides head-on with artificial intelligence. Down in those deep, hostile wells, amidst all that extreme heat and crushing pressure, Fervo and Google have actually installed extremely delicate fiber-optic sensors. These sensors act as the nervous system for the whole shebang. They are constantly beaming back continuous, real-time data on both the temperature and the pressure deep underground. And then, Google takes over. They feed that massive stream of telemetry straight into advanced machine learning algorithms. The AI analyzes the data instantaneously, optimizing the flow of water and maximizing the output of the entire system on the fly. It's this beautiful, brilliant feedback loop. The very artificial intelligence systems that demand so much electrical power are actually being used to optimize the geothermal wells that generate their electricity. How cool is that? Now, Google is pouring vast resources into this subterranean tech for one very distinct reason. They have an incredibly aggressive goal. They want to run their entire global operation on 100% carbon-free energy every single hour of every single day by the year 2030. This is a monumental logistical challenge. And I want to be clear, this geothermal initiative, it isn't just some theoretical lab experiment or a PR stunt. Not at all. This specific project is directly supplying continuous carbon-free energy into Nevada's power grid right now. It's actively fueling Google's highly energy-intensive Las Vegas cloud region, ensuring that local digital infrastructure is powered without burning a single ounce of fossil fuel. They're grounding the modern cloud in the ancient heat of the earth, proving that 24/7 clean energy is not just a fantasy, it's an operational reality. And the trajectory of this technology is honestly staggering. Fervo's initial pilot project in Nevada successfully proved the concept. Like we said, it's fully operational today, consistently generating about 3.5 megawatts of electricity. That's enough to prove the physics and the economics actually work. But they aren't just stopping at a pilot. The ambitions here are scaling up dramatically. Right now, a massive 400-megawatt geothermal facility is under construction in Utah, and it's scheduled to go online in 2026. To jump from 3.5 to 400 megawatts in just a couple of years, that represents an astronomical leap in capacity. We are moving rapidly from a successful proof of concept straight into utility-scale grid powering dominance. It's a massive signal to the energy market that enhanced geothermal systems are officially ready to compete on the main stage. So, it leaves us with this. What happens when the world's most demanding grid runs completely clean, 24/7? The entire foundation of our digital lives is currently being rewritten miles beneath our feet. By combining the blunt force of oil field drilling with the cutting-edge intelligence of machine learning, we're finally tapping into the planet's own limitless internal engine. We are looking directly at a future where the explosion of data, artificial intelligence, and global connectivity is no longer tied to the burning of carbon. So keep questioning what's possible out there, because the solutions to our biggest energy challenges, the keys to an entirely clean, unstoppable power grid, well, they might just be waiting for us 7,000 feet down.